Welcome to this video session. So for this video session, we will be discussing on a topic called as KFold cross validation, and this topics mostly we'll be looking into it in the context of machine learning. So let us see what learning outcome has been planned for this video session. So at the end of this session, student would be in a position to describe the concept of K-fold cross validation. So before moving with the next slide, let me give you a quick overview of what we're gonna look into this video session. We will be looking into the concept of cross validation. We will see what is K-fold validation and what does generally K-fold validations algorithm look like, and then we will see a small example, assuming we take a small data set, and we'll see what if we perform K-fold validation on that. And in the end, we will conclude our video session by discussing what should be the value of K when we work with real world machine learning applications. So let us proceed ahead. Okay, so before we understand K-fold cross validation, it is very important that we understand the terminology cross validation. So what exactly is the cross validation? As you all know that in machine learning, the machine learning model learns from the data, and when we say a machine learning model is learning from a data, in other words, in a layman terms, what it is doing is it is trying to train itself on a given data set to it, and once it trains, then it predicts outcome for new unseen data. So a cross validation is nothing but it's a method to evaluate machine learning models performance on unseen data. So a cross validation score or cross validation metrics, performance metrics are, they are a kind of measures which indicate how strong a machine learning model was able to learn the data, and it in turn helps the machine learning engineer to understand various effects of feature engineering, or choosing the learning type, or to revise machine learning cycle phases. So in short, as we have discussed, it helps the ML model's behavior and measure of how it learned from the data samples. So in the context of K-fold validation, the sample data is split into K parts or groups, and a machine learning model's performance estimate is obtained based on training iterations across K parts. So this is a general definition of cross validation, and often this cross validation is far more better and far more helpful and even more insightful to ML engineer when as compared to traditional train and test split of method. Like in traditional way, what we do is we split the data into train test and test split, and we directly train on that, and we come out a performance measure. Rather than that, what happens here is we split the data into K folds, and based on number of folds, now the train and test split is decided, and accordingly the ML model keeps on training on a unique set of groups, or rather than saying groups, it would be better we say unique set of parts of that data. So some unique set of parts of that data are used for training, and the remaining one which haven't been a part of training, they are used for testing. So let us look at what exactly we mean by K-fold cross validation. So a general procedure of K-fold validation goes this way. So as a first step, what we do is we split the sample into K parts, either with or without shuffling of samples. So when we have a data set and it contains a few set of records, so what we do is we split the data into K parts, and K is what here refers to K fold. So here I am referring them as part. You people do also call it as K fold. A fold directly represents a part. So to be more precise in or to be more meaningful in expressing the meaning of K fold, I am using the word parts. So a sample data set is split into K parts. Now during split, it could be with shuffling or without shuffling. In case when I say the parts are obtained by shuffling, it means that the data set is first shuffled and then the k parts are obtained. If I say no shuffling is used, then without any shuffling, k parts from the data sample is obtained. After splitting that, what we do is we randomly or in a sequence, we choose a unique set of parts of samples for training, and based on training and test split percentage, and the parts which we do not choose, they obviously they become a part of testing set. So now, as I have told you in step 1, what we do, if we decide this into 10 parts, we might choose first 7 parts for training and remaining last 3 parts for testing, provided we have decided that 70% of these parts shall be used for training and 30% of these parts shall be used for testing the ML model on. So further, once I split that in step 1 and step 2, in step 3 we train the ML model on chosen parts of data samples specifically identified as a training set, and fourth we test the ML model against the testing set, and this process is repeated. Step 2, 3 and 4 is repeated for each unique set of parts of the data sample. So this statement 5 would be more meaningful when we look at actual example. So in the end, once the step 5 is successfully executed, in step 6 what we do is, step 6 is nothing but summarization of machine learning's models evaluation score. So here instead of one iteration, it could be multiple iterations through the train set, and when we look at the way the procedure has been defined, the KFold cross validation based machine learning model ensures that each training sample is validated against every other remaining sample. So this KFold cross validation ensures that your machine learning models will make best out of the data available to it, and it in short it explores all the possibilities in the data set by going through the repetitive process of cycling through the training samples for each unique set of parts. So let us look at a small example. So now when we are looking at a small example, let us say that I have a data sample of observations, and here I have totally 9 samples with values 2.0, 4.8 and so on to 4.4. Let us say they are observations of some sensor reading, and I want to do some kind of machine learning task on this. So this is a data sample. Now on this data sample, if I want to apply k-fold cross validation, and if I decide k is equal to 3, it means that I'm gonna now split this data set into 3 parts. And when now I say I'm going to split this data into 3 parts, this shall be the 3 parts. You can see that here. Now if you look at these partitions, there is no shuffling. It means that this is a split without shuffling. Had I used shuffling here, the sequence of values in these parts could have been different. But this is a specific example of splitting the sample data set into parts, and that too without any shuffling. So after shuffling and after splitting that, based on the algorithm which we saw just few seconds back, as part of next subsequent steps, what we do is, and we decide what should be the train percentage and test percentage. So here if we make an assumption that 2/3 parts of this sample will be used for training and 1/3 for testing, then we will be using 2 parts out of above 3 samples, and 1 part for testing. Now given this assumption, we shall have following configurations for training. So config 1 could be first 2 parts shall be used for training and last for testing. Likewise, going across various combinations, you get these 3 configurations. So overall, machine learning model is built by training on configuration 1, training and testing, validating itself on config 1, next iteration on config 2, next iteration on config 3, and at the end, the overall ML's model performance shall be based on training and testing on config 1, 2 and 3. So this is a clear-cut example of k-fold cross validation. Now, so let us also look at what exactly we mean or by k, and see, the dilemma here is what should be the value of k. We have to be very clear that the value of k has a very profound effect on ML model, so this value has to be very carefully chosen. So improper choice of k value could result into overfitting or underfitting, thereby ML engineer would be facing a high variance or bias. So, and it's a very common practice to keep the value of k in between 5 to 10. As I said, it is just a common practice, but usually speaking and considering practical choice, it is usually good to choose value of k such that each fold is statistically similar to the data set whenever possible. So that's where the shuffling comes into picture. So there are various ways of sampling your data set into parts. Here comes the stratified and non-stratified sampling and random sampling. So as point number 4 says, it is always good that we take this part, that each part gives a good representation of an entire data set. But in the end, choosing the value of k often depends on various aspects of machine learning cycle, which includes data set, what are the features I'm going to learn from data set. It also depends broadly on the algorithm which the ML model would be employing to learn from the data set. So as a quick reflection of this video, if we want to answer the question goes here as the value of k in k-fold cross validation has to be always 10 for any machine learning task. What do you think? Is it true or false? You can pause the video, you can try to recall, and you can guess the answer at this point. But the answer is false. As we have seen, the value of k cannot be fixed as some arbitrary value. It depends on various contexts, but usually as we look at various models, it is usually between 5 to 10. So this is the bibliography I referred for this presentation and this video session. Yes, that's it for this video. Thank you.